Warm greetings and wishes to everyone. Today we are going to see about the video lecture on how to find the slope and deflection in the case of conjugate beam method. Before that, what is a conjugate beam? For example, if you take a simply supported beam with a central point load W and support ends are A and B and central point load position as C. So if you are able to find the bending moment diagram and able to draw the bending moment diagram, so it will be a linear triangle, so it is symmetrical about the center. So the maximum bending moment occur at C, that is WL by 4. It's a positive moment or sagging moment. Now for this bending moment diagram, again you draw the M by EI diagram, that is bending moment diagram divided by EI. So that is called as the conjugate beam or M by EI diagram. So below that, if you are drawing, what will happen? It is having a load of M by EI, downward load, which is having a maximum of WL by 4EI. So if you are able to find the reaction for this conjugate beam, so the RA and RB will be of WL square by 16EI at the support A for M by EI diagram, reaction RA. At the other end, RB is equal to WL square by 16EI. So here, the conjugate beam method theorem 1 says that the shear force at a required point, that is at point A or at point B or at point C. If you are finding the shear force, you know how to find the shear force for M by EI diagram. So that directly gives the slope at that the support A, B or at the center C. So here the reaction for the support at A and B will be equal because of symmetrical M by EI diagram, that is a conjugate beam. So that is equal to RA is equal to RB is equal to W into L square by EI, where capital W is the load applied at the simply supported beam at the central point. L is the span of the beam and EA is the flexural rigidity of the beam. So this M by EI diagram is very important in calculating the shear force or the bending moment. So the shear force directly give the slope at this support A and B. You know the reaction at A and B are equal to is WL square by 16EI. So therefore the slope theta A is equal to theta B, that is equal to WL square by 16EI. Now the conjugate beam theorem 2, which states that for a given M by EI diagram, find the bending moment of M by EI diagram at the required point. For example, we are finding the slope deflection at midpoint, that is at C. So YC is equal to delta C is equal to delta maximum, that is maximum deflection at that point. So what will happen here? So here you have the reaction, which is WL square by 16EI into the corresponding middle of the beam, that is at C you are going to bend moment, so into L by 2 minus, now I am taking half the span, that is AC or CB portion. So for that M by A downward load diagram, the bending moment is minus anti-clockwise moment because due to the M by A diagram loading. That is half of B is L by 2 into H is WL by 4EI. So if you are simplifying it into X bar value you have to take, here X bar is equal to, the base width is, so you can say it is at point C to the XX value, that X bar is equal to 1/3 of L by 2. If you are simplifying this, the moment at point C for the given M by E diagram, which will give WLQ by 48EI. So which will be same of other previous method like double integration, moment area method or the Mercallis method. So therefore the slope at A and B theta is equal to theta b, that is equal to W L squared by 16EI, and the deflection at C is the maximum deflection. So we are simplifying the M by E diagram by taking moment out C. For the M by E diagram loading, you are getting WLQ by 48EI. So this is about the slope and deflection at the support end and at the center C. So like that, you can find the slope and deflection wherever it is asked, either at L by 4 or 3/4 of L. So or 0.35 L, wherever it is required, you can find the shear force at the point that directly give the slope, and we are finding the deflection for the given M by A diagram and taking the moment that it gives the deflection. So I have done a worked out example for a simply supported beam, what I have explained. So this is about the slope and deflection at this point. So this is the way you have to work out the slope and deflection for any type of beam. Thank you very much for patient listening. God bless. வாழ்க வையகம், வாழ்க வளமுடன்.